Okay, so welcome back to Pre-Calc 11, Chapter 2, Section 3B. So this is sort of the continuation of 3A. But before we actually begin our lesson, I just want to introduce an idea. All right, so if you actually have a room, right, and so here's a room, and what I'm going to do is I'm going to draw a door. Oop, I'm going to draw a door, and hopefully this door would line up at 90 degrees to the wall, right? Now, if the door were to swing open, the length of the door is the exact same length here as well, right? And of course, if you were to swing indoors, it would be here, right? But it's the same length all throughout. So we can recognize that the door length is all exactly the same. Now, that exact same scenario, if you have a room, right? So I'm going to draw a room again. Now, what would happen is if you had a door that was really, really long, can it actually swing this way and would it be able to close? Well, hopefully you would realize that this length is too long. Now, if you were a really bad carpenter and you installed your door, it would get stuck, right? It would hit the wall here. Or if you installed the door and the door was too long, it would get stuck here, right? And if you were trying to swing here, it just wouldn't fit. Okay? So that's the most important idea. All right? So you might have to watch this portion in the first 2 minutes of the video again, just to understand. Now we're looking at your room from the top, okay? From above. And this green line represents a door that swings back and forth. This swings perfectly because the door is exactly the same height as this portion of your room. Whereas this door is, obviously I've drawn it so that it's longer than the height of this side of the wall, right? Okay, so if you get that idea, then we're going to move forward. So here's the lesson. We're going to talk about this thing called the ambiguous case. And the word ambiguous means you're not exactly sure which triangle you're going to create. All right, it says here, so far you've learned how to use trigonometry when working with right angles. Oblique triangles are non-right angles. When solving a triangle, you must assess the information given to determine if a solution exists. So far, the triangles we've worked all have solutions. So we've been given the measures of two angles and one side. So it's called ASA, angle, side, angle. And the triangles have been uniquely defined, which means there's only one possible triangle. However, if you're given two sides and an opposite one, SSA. Now, in the notes it says SSA, but sometimes it makes life a little funnier if you think of it as an AS, angle, side, side. So if you get one single angle and two sides in that order, then you get an AS. And if you get an AS, then you're not sure. It says here, the three possible outcomes are for acute triangles. Okay, the word acute just means all the angles are less than 90. All right, so no triangle exists. So that's a possible combination if you get an AS. No possible combination, you get exactly one triangle, or you get possibly two different triangles. All right? So the possibilities are summarized in the diagrams below. All references and relationships between side A, B, and the height of the triangle H, and the angle opposite to the one of the sides. If the angle is not opposite one of the sides, this situation is not an SSA, or as I call it, an AS, ASS. And the ambiguous case does not apply. All right, now, if you get an AS, here's the problem, right? You're given an angle, here's your angle, and your two sides. All right, so we start with the angle, side, side. So you don't know what this angle up here is. Now, here's the problem. In the beginning of this lesson, I said, imagine this is a door. If you were to swing this door, obviously this door is too short. It doesn't reach the wall. That means there's no possible triangle, okay? Case number 2, and again here is the length of that door. It's exactly the height that we needed, and so you get exactly one possible triangle. Okay, so this is a door that swivels back and forth like you're going into a store at a restaurant, a store at the mall. Okay, now it says here if length A, notice that's lowercase, if length A is really, really long, and if it's bigger than the first side of your AS, right? So here's your angle, here's your first side and here's your second side. If your second side is bigger than the first side, there's only one triangle. Now here's the ambiguous case, right? Here's your ass. Here's your A, you know this angle, you know this side, and you know this side. But notice that this side and this side is the exact same. So you don't know, it's like the story about the door, it's too long. So you don't know if you install the door, it won't close on this side. If you install the door on the inside, it won't close on this side. So you get what's called the ambiguous case. Okay? So if all that makes sense, you might have to watch this video a couple of times, but if all that makes sense, we're going to move on to our first example. All right? So it says here, how many triangles are possible given an angle A, first side, second side? So here's your ass. So I always draw it like this. Okay? So this is going to be my angle A, and this is going to be 50 degrees. Now, angle A, side length A, well that's this side, and I'm always going to use dotted lines to represent side length A, right? Angle A and side length A are opposite to each other, so that's 10. This is going to be 6. So the first thing we need to do is, in order to determine if you have zero solutions, one solution, or no solutions, well, what do we notice? We notice that side length A is definitely bigger than 6. So A is bigger than B. So we've seen that right here. A is bigger than B. So right away, no calculations needed. We know there's one solution. Okay, one SOL, what looks like a power of n. All right, let's move on to the next one. Example 2. Example 2 says, how many triangles are possible if you've got an angle A of 28 degrees, side length of A of 4, and B of 8.4? So I always start like this. So I know this is A. I'm going to draw my dotted line. I have no idea if it swivels or if it hits straight up and down. I have no idea. So I always leave myself the option of it being able to swivel. So this is going to be 4, right? A is opposite little a. B, well, that's going to be 8.4. Well, first of all, is A bigger than B? So it isn't. So we're not sure. So the next thing we want to do is we want to calculate height. And the formula for calculating height is equal to B sine of angle A. Now what is B? B is 8.4 sine angle A. Oh, it's 28 degrees. I forgot to write that down in here. So it's 28 degrees. What is that height? Well, that height is 3.9 centimeters. So think about this for a second. If this is 3.9 and this length is 4, how many possible triangles are there? Well, this length 4 is definitely too long, so it's going to look something like this. Okay? And I'm just exaggerating the drawing, but length of 4 is definitely bigger than 3.9. And again, I apologize for my handwriting. So how many possible triangles are there? Well, there's actually 2 possible triangles. And the way it's going to look like is, let me blow it up a little bit bigger. So this is 8.4. This is 4. We know that this height is 3.9. That means 4 is going to be on this side as well. Now, what's going to be kind of useful is, again, I apologize for my messy penmanship, but this is 4 and this is 4. Hey, what kind of triangle do you have on the inside? Hopefully you can recognize this is what's called an isosceles triangle. That means eventually we're going to need to know that these angles are the same. We don't know what they are right now, but we can at least find out in the future. And this is, of course, 28 degrees. Okay? So I want to make sure you understand how many triangles are there. Well, here's one of them right here. Oh! Let me go back. Here's one of them. That's one triangle. Right? And then the other triangle I'm going to do in blue, which is this triangle that I'm just doing on the outside. So ambiguous case means you have no idea which triangle we're referring to. It's either the one in green or the one in blue. Okay? Alright, example 3. It says, how many triangles are possible? Angle A, 75 degrees, length A, 4, and B, 12. So again, we always start off with angle A because it's an ass. So here's my A. This is 75 degrees. 75 degrees, and I'm going to draw a dotted line here. So this is 4, and this is 12. So first thing I always check is A bigger than B? Nope. So I'm going to move forward. All right, I'm going to find the height now. The height is B sine, H is B sine angle A. B sine angle A is going to be 12 sine 75. I'm not going to bother showing you the calculations because I've already done it somewhere else. It is 11.6. Oh, I should have units, meters. Well, if I know that the height, all right, if the height is 11.6 meters, 4 meters, well, this door, right, we talk about a door, will it even reach the bottom here? The answer is no. So if it doesn't even reach, how many possible triangles are there? There's none. There is no triangles because this door is super duper short, right? It swivels back and forth and doesn't touch this end of the triangle. So there's absolutely no answers to this one. Okay? Now, for obtuse triangles. Now, obtuse triangles are a triangle that has one angle, only one angle that's greater than 90. And there's only 2 possible outcomes. So no triangle exists because you have your angle A, you have length A, length B. It says here if A is less than B, or if A is equal to B, again, it's the sort of the door, right? If A is less than B, the door doesn't even reach the base or the wall, right? It's too short. If A is equal to B, that means all it does is it lines literally up right onto B. So the only way you can have a triangle is, of course, this case, where A has to be bigger than B. A has to be longer than B in order to reach the wall, right? Okay, so let's do example number 4. It says, how many triangles are possible if A is 115, length A is 3, and B is 9? So 115, so now I'm going to draw an obtuse, right? Something bigger than 90. So that's 115. This is length 9, right? And this is length 3. Right? And again, I'm not going to bother filling this in because I'm using a tablet and I can barely write on this. So how many possible triangles are there? Well, right away, this length 3 is shorter than 9, so there's no solutions. Okay? I hope that's obvious. No solutions. The next one is how many triangles are possible when A is 100 and A is 10 and B is 8? So I'm going to draw my ass again. So here's my ass. This is 100. I'm going to write it here. I know I couldn't do it earlier. B is 8. And this time it's 10. A is 10. Hey, look at that. This is longer than this. So right away we know it's one solution. Okay? Hopefully that's obvious. Example number 6. As we burn through this, it says here sketch and solve. Sketch and solve the answer to the nearest tenth, which just means 1 decimal place. All right. So length A is 23, length B is 6. So obtuse. So here's 115, and again my handwriting is terrible. All right. So this is B is 6, and this is 23. All right. This is angle A. This is length A. So we have corresponding angle inside. This is length 6. So right away it says solve. What that means is I want to find this length here in blue. I want to find that angle. I want to find this angle, and I want to find this length. Okay, so let's begin. I'm going to apply the sine law right away, right? So if I'm looking for an angle, I'm going to label this B. This is little b, this is C, and this is little c. So if I'm looking for an angle, I know that 6 and C are corresponding, so I'm going to put my angle on the top. Sine C over 6 is equal to sine 115 over 23. And then I just cross multiply like before. Sine C is equal to 6 sine 115 over 23. Right? I'm not going to bother showing you the calculations. I know you have to do the second inverse, or second function inverse. Angle C, measure of angle C, you can do it yourself. Works out to, I believe, if my calculations and my notes are correct, 30, hold on a second, 50, yeah, about 51 degrees. 51.3 degrees. My handwriting, 51.3 degrees. Now, if this is 51.3 degrees, we know that this is 115. We automatically know measure of angle B. Measure of angle B is roughly 13.7 degrees, right? Because we know that the sum of the angles are 180. Now, to find length B, well, now I'm going to put length on top. B over sine 13.7 is equal to, and again, always use the original pair, all right, in your calculations. So it's going to be 23 over sine 115, and then we do the little cross multiplication. B is equal to 23 sine 13.7 over sine 115. And again, I won't show you the calculations, but length B works out to, based on my notes, let me just cheat a little bit, I think around 6 meters. Okay, so I'm going to put boxes around all these pieces of information because that's kind of important. Alright, and our last problem. Alright, so this is the last example, question, or example number 7. We've got my ass, angle 38, 8, and 6. And so I'm going to draw it. I know it's acute, right? Smaller than 90. So this is going to be 38. Side length is 8, and this is 6. So this is definitely bigger than 6. So there's only actually one triangle, and this is it. So as soon as B is bigger than A, there's only one triangle. Or sorry, as soon as A is bigger than B. All right, as soon as A is bigger than B, there's only one triangle. And so I'm going to apply the sine law now, right? So I've got sine 38 over 8 is equal to sine of angle B, right? This is B over B. I'm going to use a little bit of trigonometry, 6 I should say. Just going to cross multiply, and I know that sine B is equal to 6 sine 38 over 8. And then I know that we're supposed to do the second function inverse, but I'm not going to bother showing you that. Measure of angle B is 27 degrees. So now we just discovered what angle B is. Now, we automatically know what angle A is, right? Because measure of angle A is equal to 180 minus 27 minus 38. And so measure of angle A, did I say angle A? I meant angle C. Measure of angle C is going to be 115 degrees. Right? 180 minus 27 minus 38. Now the only thing left to do is find, I don't know why I wrote A there. That's actually C, and this is angle A. Now little length C, I'm going to do the sine law again, so it's going to be, I'm going to put the length on the top. Sine of 115 is equal to, and always use the corresponding pair that you have from the beginning, okay? And so this is going to be 8 over sine 38. I don't know why I'm making so many mistakes. Anyway, C is equal to 8 sine 115 over sine 38. And I'm not going to bother showing you the calculations, but it works out to around 11.8 meters. And then you're done. Okay? You might have to watch this video a couple times just to understand that whole idea of the ambiguous case. Just imagine a door swinging. If it's too long or if it's too short, will it close? All right?